Test. 1, 2.
Hello. Is the author of the paper Sustainable Energy Generation Trend Insight from Python Analysis existed or not?
Yes, sir.
Okay. Could you share your screen, please, and start your presentation?
Okay, sir.
Okay. Okay. Go ahead.
You can see my PPT.
Not yet. Click share again.
Now,
Not yet.
wait a second.
Stop sharing and hmm? Okay.
Now you can.
Yours. Okay.
Now you can
Just
see.
no. Just a moment. It's okay. Green one. Green one. Green. Mm. Start your presentation, doctor. Yeah,
Okay.
it's okay. It's okay. Go ahead.
Good morning, everyone. Myself, Hassan Jaman Ananto. So my paper title is Sustainable Energy Generation Trends Insight from Python Analysis. So here is the first part is an introduction. So global energy transition and Netherlands renewable shift. So global context, the global push to transition from fossil fuels to renewable is central to combating climate change and reducing carbon dioxide emission with energy systems being a major focus of this transition. So energy security, renewable energy offers a sustainable solution, reducing dependence on fossil fuels while enhancing energy security through diversification of energy sources. In Netherlands energy transition, so traditionally reliant on natural gas, but recent years have seen significant growth in renewable energy, especially wind, due to favorable geographic conditions. The transition is supported by EU climate target, the Netherlands on ambition and renewable energy goals. So energy focus, energy generation trends. So this study focus on analyzing energy generation trends from traditional fossil fuels like gas, coal to renewable sources like wind, solar in the context of changing energy mix and data tools. Python is used in a exclusively for data pre-processing and time series trained to analysis visualization, leveraging libraries like pandas and matplotlib and seaborn and scikit-learn to handle the larger dataset and generate actionable insights. The second point is a key finding in renewable growth. So in 2030, the renewable energy production in solar and wind exceeds meetings around 50% Netherlands electricity demand. So solar market shared 17.6% contribution, about the 50% of total energy production. So second is grid stability and challenges. So as a renewable penetration increase, grid stability is a concern due to intermittent nature like wind, solar power, and many other things. So managing surplus energy, ensuring the reliable remains crucial, and with the natural gas playing a role through it being paused out gradually. So technical and economic implication challenges, the increasing of role renewable poses technical such as grid reliability, negative electricity pricing, and the need for expanded storage and back more researching need to improve forecasting and plan for fluctuating demand patterns. So third is policy implications. The transition of towards renewable will require significant investment in infrastructure technology, addressing both economic and technical challenges. However, it represents sustainable towards the Netherlands sustainability and climate goals. So fourth is future outlook energy mix evaluation. This energy mix is expected to contribute shifting towards renewable, particularly offshore wind, which fossil fuels playing a diminishing role. However, gas will continue to provide backup support for grid stability and ongoing research. So further research in needed integrated renewable energy sources effectively into the grid, address negative pricing issues, and develop better forecasting storage solution to manage the long-term energy transition. So this is the data cleaning process. So first is crucial step. Data cleaning ensured the data set was prepared accurately for further analysis. Then missing values for hydro pumped storage and solar water heaters, 100% missing data and indicating no activity or incomplete records, leading to exclusion. And other categories, a very small proportional like 0.08% of missing data is fossil gas and wind onshore solar addressed through automatic imputations. So impact of analysis, the cleaning process allowed the study proceed with the reliable and complete data, ensuring that analysis was based on comprehensive and precise information. So data integrity, so the clean data set provide an ambulation and accurate representation of energy trends essential for understanding the contribution of renewable and non-renewable energy sources in the Netherlands. So there is the energy generation block diagram management, how to smart home integration systems. So there is the data aggregation objective. So data set was originally collected on the minimum value of a basis, then aggregated to daily and hourly totals to simplify analysis. What is the benefit? So aggregating the data reduce the complexity and help identify long-term patterns, providing a clear understanding of energy production trends over different time periods. The impact of a visualization. So daily and hourly aggregation enable easier to tracking of energy generation patterns. So trend analysis and comparison. First is trend in total energy production goals. So analyzed overall energy production to identify long-term growth, decline, or especially as a renewable energy sources increasing prominence. So key trends of major energy sources finding: solar and wind energy generation flow, seasonal patterns with a solar peaking in the summer, wind being less predictable. Fossil fuel production remains steady throughout the year. So there is the result part. First is a daily renewable and non-renewable energy production. So renewable energy growth between September 22 and February 24, renewable energy production stability increased as the Netherlands shifted toward more sustainable energy sources. This aligns with the political and policy efforts to reduce fossil fuel dependence and the non-renewable energy production, mainly fossil fuel gas, showed higher volatility with the fossil gas overtaking coal for the first time due to market condition and seasonal demand and weekend patterns. So energy production is generally lower on weekends, reflecting reduced demand for electricity or fewer production units in operation. Implementation of grid stability. As a renewable energy grows, so balancing strategy will be essential to maintain grid stability, requiring better understanding of energy consumption patterns. The second figure is average hourly solar energy production. So daily cycle of solar production is solar energy follows a clear daily cycle, peaking and around midday, or sunlight is optimal or disappearing at night. So seasonal and weather variability, solar production fluctuates depending on the time of year and weather condition. During the summer and sunny days, output is higher, while cloudy days or winter months see reduced generation. And storage needs to accommodation solar energy variability, effective storage solution. So the grid performance and prevent issues like a negative pricing on the sunny days. There is the daily energy production sources, so solar, wind, and fossil fuel. So offshore and onshore wind power. Offshore wind benefits from stronger and steadier winds at the sea, particularly in winter, so making more reliable during colder months. This geographical advantage significantly impacts energy production potential. So fossil fuel dependence, despite the growth of renewable energy, fossil fuel, particularly fossil gas, are still essential to meet high energy demand. Fossil gas production continues to surplus coal, and fossil gas plays a crucial role as a backup power source, especially during periods of low renewable generation, cloudy days with little wind. So transition from coal to gas, the decline of coal uses indicates a shift towards more environmentally friendly energy sources. However, fossil gas remains a necessary stopgap during time when renewable energy generation is a insufficient. Highlighted the transition nature of Netherlands energy system, the transactional period. The country is moving away from oil gas, but there is still a reliance on their fossil fuels for stable power production. This situation points the need more balanced energy mix. Netherlands gradually shift to general energy sources. So there is the fifth figure is average monthly wind energy production. So seasonal variability wind energy production in the Netherlands is strongly seasonal with the higher output during the winter months. So when wind are generally stronger, offshore wind farms with their more stable wind condition constantly out from onshore wind facilities. So offshore and onshore. So offshore production range is 1400 to 1600 units per month, and onshore production range is 585 to 590 units per month. So if impact of grid planning, the higher and more consistent output of offshore wind driven by stronger and steadier at sea, so should be prioritized in energy planning. This insight is crucial for ensuring a stable grid during variable wind condition. So figure 6 is correlation here, heat map made between energy sources. So complementary relationship, the correlation heat map reveals a weak negative correlation between solar and wind energy production, and the strategic implication, this is a complementary relationship from energy planning production in complement each other by offsetting each other performance. So energy storage solution, this renewable energy storage solar and period of low wind. So green management. So by understanding the difference of implementation studies like the enhanced grid stability, such using energy management techniques to smooth our renewable fluctuation. There is the average energy production by sources. So renewable energy, solar energy contributes a small 0.4%, and while offshore wind provides a significant 15.5% and onshore 5.1%. Highly wind power growing importance. So non-renewable fossil gas remains a dominant contribution 49.6%, while fossil coal accounts for 23.3%. So nuclear contributes a smaller but steady 6.1 grid. So challenges variable renewable require advance of grid management and storage maintain balance. So figure 8 is variable in energy production by sources. Output for offshore and wind lifts for 18,070 units and follow the 5,500 units. Fossil fuel 2,460 units, and nuclear is 450 units. There is the last figure is average energy production weekdays and weekends. So there is a table of a summary of the energy production, how much they produce weekdays and weekend and monthly production units. The conclusion of this paper is that this study highlights the significant role of renewable energy in Netherlands energy mix with wind energy, offshore and onshore, showing sustainable growth, and solar energy, while growing, remains dependent on weather condition, requiring better storage solution for grid stability. And fossil gas continues to play a key role during low renewable generation, demonstrating need for balanced energy transition. Understanding seasonal patterns and dependence along energy sources is critical for effective grid management. What is the future work? So future research could focus on improving energy storage technologies and exploring more advanced grid management system for better integrate renewable sources. Additionally, further studies could analyze the impact of upcoming policies and technological advancement for the energy mixes. And this is the limitation for this paper. This study is limited by the ability of the data for certain energy sources, and particularly regarding the long-term impact of storage solution policy changes and variability in renewable energy output. It impaired grid stability, need more comprehensive analysis with additional data and modeling technique. There is a reference of this paper. Thank you, everyone.
Thank you very much. Is there is a question from the attendee to the author? Is there is any question? It's okay. I have a couple of comments, really. It's not a question. In the abstract, you mentioned that the result reveals that by 2023, nearly half of Netherlands electricity demand will be met by renewable source.
Yes.
My dear, we are now in 2025. Is this some mistake or what?
No, this actually, when we collect from the data is 23 data from Netherlands, so that's why 23
You
actually.
say you say the future will be يعني in the future يعني
For the future work, and will be
consider
updated the
that
data.
you consider that 2023 is not yet.
Not yet, but in the future, we implication of the data of
طيب.
25.
This is a comment, but also in figure 6, please return to figure 6.
Yes, figure 6.
Yeah. How you calculate this value? I know that this is a horizontal is a source of energy and vertical is another source of energy. And of course, the diagonal will be 1 because dividing this over this will be 1. What about the other value? How you calculate these values?
Oh, actually, the solar and wind energy production generate more
And what is
in
the
different.
what is the reason that the column become negative or positive?
Oh, negative is only when it's solar typically peak on sunny days or when the wind condition are calm. So there's the negative, and in positive, so it's stormy and cloudy weather when the solar generation decrease.
يعني what يعني it's a ratio between energy over energy or what?
No, there is no issue actually. So the negative
Or
actually
this is the or this is a log value or whatever. What is the reason for negative value?
so negative is actually the energy sources like solar when the sunny days, and wind condition are likely calm, not cloudy or not a stormy weather.
طيب, we know that the main problem of renewable energy is how to store this energy. If
Yes.
we extend in generating renew energy from wind or from the solar, how we can store it?
How we?
How we can store this energy for the time to consume?
Oh, actually, the energy is consume actually for backup power, peak renewable energy generation times.
Okay, thank you very much. Now we will go
Sorry,
to
I have a
the
question.
Okay, you have a question from one of the attendee. Go ahead, please. You can ask. Who need to ask? Okay. We will go to the next presentation paper entitled Comprehensive Study of Macro Surfaces Architecture in Comparison with SO and Monolithic Model.
Yes, I am here.
Okay. Yeah.
Can you see my
I make you a host now.
Hello everyone. My name is Chaudhary Abidanju
Mhm.
Ira. I am one
Ira?
of the hello.
Yeah,
Am I
hello.
Am I audible?
No, not the presentation is not shown until now.
Okay, but I already shared my screen.
I make a sharing. No. Start again. Start again.
Yeah. Okay.
Yeah, disappear now.
Thank you.
You have 15 minutes for presentation and 10 minutes for discussion, inshallah.
Yeah, inshallah. Hello everyone, my name is Chaudhary Abidanjum Ira. I am one of the co-author of.
Sound, voice is very low. Make a
Okay.
voice louder, please. Your voice not coming.
Hello.
Aywa, hello. Your voice not coming.
Hello, am I audible now?
Yeah, but a bit louder, please.
Okay. Hello.
Yes, hello.
Yeah, now it is clear.
Yes, very good. Go ahead.
Yeah. Yeah.
Hide the volume. Hide the volume, please. Yes, okay. And
Yeah.
enlarge the presentation.
Yeah.
Yeah, go ahead.
Hello everyone, my name is Chaudhary Abidanjum Ira. I am one of the co-author of a comprehensive study of microservice architecture in comparison of SOA and monolithic architecture. So let's start with the introduction. So these days, the requirements are growing faster than ever, and new technologies are being adopted, making system bigger, more expensive, and sometimes more complex. So finding a suitable architecture for software creation in last few years has been challenging. In software development, microservice architecture, or you may say MSA, has emerged the newest trend. So now to adopt this architecture, there are several advantages and also disadvantages. The challenges includes difficult to scale up, and sometimes maintain is also complex, and directly couple components like make modifications challenging. So these are the challenges of the monolithic architecture, but we can solve this problem by the microservice architecture. And we in this paper we also add the comparison with the service oriented architecture and monolithic architecture. However, people still need to gain proper knowledge to implement a microservice architecture. As a new technology, microservice architecture has many uh, um, uh, new rules and also security issues, which is one of the significant issues that need to be resolved. This study basically discuss some potential advantages of microservice architecture and also the comparison between these three architectures. So for these studies, we have go through some related works regarding this architecture. So the big companies are adopting microservice architectures, and they are gaining success from that. One of them are Netflix, which has transitioned to the microservice for better scalability and resilience. And then Amazon, which who has improved performance and reduced deployment time. And then the SoundCloud, which has achieved independent service update without affecting the entire system. And then uh, previous studies on architectural models. So many studies shows that increasing migration from monolithic to microservice and service-oriented architecture is still used in cloud-based application, and microservice provide, but in compared to the other two architecture, microservice provide more flexibility, but it also introduce complexity in management. And while shifting to however, the oldest widely used architecture is monolithic. It is a good idea to begin with a project with this kind of architecture, as it's enable one to investigate the boundaries between the components of a system and its complexity. And while transition to the microservice, larger team face difficulty in refactoring the monolithic architecture, and also sometimes ensuring seamless communication between service is a major concern, and also the security and deployment dependencies. So from this related study, we have formulated 3 research questions. First one is, what can be the most preferable architecture while designing any project and software? And then, which methodologies are followed by the researcher? And what is the most significant potential risk in microservice architecture? So here is the comparison of architectural approach. So first, start with the monolithic architecture. So this section actually describe the answer to the research question 1. With the client-server architecture and SOA and structured components, monolithic architecture has evolved. And here, the main thing is single application with all components tightly integrated. And here, the main problem is the main advantage is the simplicity in the development and also easier debugging. But when it comes to scaling and also can be adopted for larger applications, it becomes really difficult as the components are really tightly coupled. And then the service-oriented architecture. So for this, the project is divided based on the service of each application, and it encourages the reusability and also the interoperability, and this uses centralized governments and middleware. So the pros is reusable service and also support integration with legacy system, but the complexity is in the management where when the system gets larger. And finally, the microservice architecture. Here we can create some independent services that communicate via APIs, and also the decentralized management and deployment, which is vital for a larger project and to operate the project from cloud or anywhere. And then it helps us to create a agile project management, and also it is scalable, and anyone can deploy any part of their functionalities or anything independently. But the cons is as a microservice has some complex architecture, so everyone should know how to operate that. And here the methodology used in implementing architecture. So while researching about the related works, we have found some common thing which is related to the microservice architecture. So this slide is basically the answer of research question 2. So here first, the evaluation of architecture is using JS Hipter framework. So this framework is used for Angular JS and Spring Boot applications. So here, microservice compared based on by using this framework, the microservices are compared based on the performance, scalability, and maintenance. So then for the comparison, the text scenario for comparison, the 3 things are tested. First one is load testing, and then the concurrency testing, and the endurance testing. So load testing measures the response time under the heavy user load, and concurrency testing evaluates the simultaneous request handling, and then the endurance testing checks the system stability over the time. And we also found some a popular design pattern, which is the first one is the service discovery pattern. So this is basically register services for dynamic lookup, and then the circuit break pattern. So it's prevent the cascading failure in a network. And then the API gateway pattern, it acts as a unified entry point for services. And domain driven design is actually it creates different domain for each functionalities. And the CQRS, common query responsibility segregation, it is basically separates the read and write operation. There is no need to take the read and write data from the same API or same command. So this facilitate better results in compared to the other design pattern. So the availability of comprehensive resources is challenging due to the recent evolution of the microservice. Therefore, various sources, including tech talks, web articles, blogs, and publications, were gathered to examine, and this helps to compile a list of main obstacle of the implementation and the shift to the microservice. So following this, authors devised a solution where they are basically doing this kind of things. So one of the so these are the methodologies basically used in the microservice architecture. And now let's jump into the advantage of the microservice architecture. So first one is scalability. So one potential advantage of microservice architecture is operational scalability. So the ability of a system to add resource to handle the fluctuating volume of request is measured by the scalability. So there are two types of scalability. First one is vertical and the second one is horizontal. So both involve adding more resources to the physical units and the logical units, because it allows microservice instances to scale out quickly and break down the monolithic architecture into the independent one. And then the agility. So one of the main problem with the monolithic corporate system is the lack of agility. These are considered obstacle to the digital business project. So microservices were recognized as the possible remedy for this problem, and therefore it was believed that microservice architecture has the ability to support the heterogeneous technology stack, would greatly encourage the experimentation and the creativity. And then the third advantage is the maintenance. So compared to the monolithic architecture, the code of a microservice is more straightforward to understand because it is limited to single capacity. So little bits of code can be loaded by the IDE, which lightens the build, and programmers can more quickly develop new features and get a new sense of side effects of the changes when they work with the smaller code bases. So it is either the primary factor driving the migration, or it can seen as most evident improvement over monolithic or service-oriented microservice, which by nature nature were modular by design and allowed for independent release cycle and agility. And fourth one is the load balancing. So the goal of load balancing for microservice is split up incoming network traffic among the several service instances, so that no instance is overloaded. So distribution of traffic makes sure that every service instance is utilized effectively. And then comes to the risk of the microservice architecture. So first one is the security. So microservice imply the applications are dispersed across multiple platforms or service, many of which are in public clouds under platform as a service, software as a service, or infrastructure as a service arrangement. So monitoring and debugging applications from the different interfaces can be complex, with the chance of loss of security. And the cloud environment, user adopt a different third-party solution. Still, in this case, user have to take the risk of security to host microservice such as database and API gateway. So, on the other hand, flaws in service-side request recovery arise when a API retrieves a remote resource without verifying the URL provided by the user. Even with a firewall or VPN in place, the cause of application to drive a different message to unspecified location as a threat. And then the cost, with microservice, we can developers or project manager can purchase an extra degree of flexibility. So microservices are not accessible, accessible their development, and Unkeep are highly costly. If you require more flexibility, the expense will eventually be recoupled, and microservices are something to take into consideration when dealing with such intricate applications. However, microservices usually add cost and complexity, forcing enterprises to engineering their tech stack and divert funds from customer value adding project. So in conclusion, we can say that microservice architecture is a modern solution for scalable and agile software development. And in compared to the comparison to other architecture, monolithic is simple but hardware scale, and is service oriented architecture is reusable but also complex, and microservice architecture is scalable, flexible, but requires the careful management. So organizations are really trying to adopt the microservice architecture day by day. So in future, the microservice architecture will be expected to dominate the enterprise software development, and also increased automation in deployment and the monitoring tools. So here, these are the important references, and that's all from my side. Thank you.
Miss Era, do you hear me, please?
Yeah, sorry, I can't
Uh,
hear you.
I'm talking about the macro architecture. It's a single process for each surface. Is this true or what?
Can you please repeat the question?
One process for each surface. If the system consists of many surfaces, you will make many process for this system. Each process is used for a certain or a specific surface, and they communicate over the HTML or HTTP or whatever communication
Yeah,
media.
yeah,
Is this true?
yeah.
You have calculated the cost and the performance of system architecture based on monolithic and microservice architecture in order to know what is better regarding to the performance?
Basically, we haven't calculated the performance metrics, but it's different research work where they have used this kind of results to test the like the performance of these architectures.
Because يعني according to your presentation, microservice architecture need to communicate between different processes.
Yeah.
طيب, we pay price for that communication cost. It's not
Yes.
seen in your, maybe it's in the load balance, maybe it's better because you can distribute balance between different machine and different and so on. But
Yeah, maybe
in same
in future.
time, in
Mhm.
same time, communication cost, it's neglected in your thesis, really.
Yeah, maybe in future we will try this as a new
Yeah,
work.
time, communication mean time.
Yeah.
يعني when you communicate process on a machine A with another process on machine B, it takes some time.
Yes.
But if the whole system is implemented as a single process, the communication will be on the same machine.
Yeah.
So cost will be less in case of monolithic, I guess. So يعني this point you have to consider, please.
Yeah, sure.
Okay, thank you very much, Mrs. Iram.
Welcome. Love.
Now we will go to the next paper entitled Dual Band Low RA GPS Dipole Antenna with Harmonics Suppression Capability. The author of this paper can start now. It's okay. You have 20 minutes, 15 for your presentation and 5 minutes for question, please.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good morning to everyone. I'm Shipun Anwar bin Hamzah from Malaysia. Now Malaysia currently is 2:30 p.m. Okay, first of all, I would like to express my sincere thank you. Thanks to Chairperson for the opportunity to present today. Before I begin, allow me to introduce myself and my research team. Okay. Okay. My research team is Ahmad Daniel Abdul Aziz from UTHM Malaysia. Me, Shipun Anwar bin Hamzah from UTHM. And then Muhammad Nur Dalimin from University Muhammadiyah Malaysia. Khairul Nizam from UTHM Malaysia. And then Muhammad Sani Yahya from University Technology Petronas Malaysia. And then Professor Fauzi Hanim from UTHM Malaysia. Associate Professor Dr. Wahyu Mulyo Utomo from UTHM Malaysia. And then Professor Bilal A. Kawaja from University Islam Madinah, Saudi Arabia. And then Shailah Nordin from Malaysia and Muladi from Indonesia. Okay. Today I'm excited to present our study entitled Dual Band LoRa GPS Dipole Antenna with Harmonic Suppression Capability. Okay, basically this project focus on designing a printed dipole antenna with 3 key features. Number 1, dual band functionality. Number 2, compact size. And then number 3, it has a capability to suppress the harmonic frequency. And then actually the core design of this antenna, it's operate at 900 megahertz with double-sided dipole structure. And then we designed the antenna to work within the LoRa frequency bands at 916 megahertz and the GPS frequency band at 1.57 gigahertz. And then this antenna, we incorporate a parasitic element to control the second band frequency. And then we add a stub to suppress the harmonic frequency. To achieve a significant reduction in size, a tapered balloon is used, which offer 75% size reduction compared to the original tapered balloon. And then for the design process, we use a combination theoretical calculation, simulation using CST software, and fabrication using wet etching technique. And then this antenna is intended to use in IoT system, specifically those operating within the LoRa and GPS network frequency band. Okay, this is my outline of presentation. First, I will give briefly about introduction. I will highlight on the method of the design for dual band, and then the method of design the harmonic suppression capability, and the I will highlight how we can reduce the antenna size. And then number 2, antenna design. I will explain how we design the antenna. And then number 3, results and discussion. I will explain about the finding obtained. And then finally, I will conclude and give a future works of our study. Okay, introduction. Okay, a multiple band dipole antenna is popular to be used in a wireless communication system, including LoRa networks working at 433 megahertz, 868 megahertz, 916 megahertz, and GPS at 1.57 gigahertz for Internet of Things IoT application. Okay, this type of antenna is capable of operating at multiple frequencies, enabling communication across several frequency bands simultaneously. And then this provide flexibility, cost efficiency, and reduce the space requirements in various application. Okay, the design of this antenna can be achieved using various methods, including the use of parasitic element, slot technique, or folded dipole structure, all of which aim to deliver efficient multi-band performance at various frequencies. A printed dipole antenna combined with a compact balloon circuit allow for a reduction in physical size. Okay, multiple band dipole antenna using parasitic elements operate at frequency of 0.6, 0.9 gigahertz, 2.45 gigahertz, and 5.8 gigahertz has been proposed in reference number 1. And then a slot used in a bow tie dipole antenna generates 3 operating frequency band as reported in reference number 2. And then the folded dipole techniques is used to design an antenna operating at 896, 1785, and 211 megahertz respectively, as reported in reference number 3. Okay, in many communication application, the presence of harmonics is undesirable and should be minimized. Therefore, the use of stops to suppress this harmonic is crucial, as enables the antenna to maintain its size without the need for external filter. This paper presents the design of a small dual band dipole antenna operating at frequencies of 916 megahertz and 1.57 gigahertz. To suppress harmonic frequency, stubs are used. Previously, a dual band dipole antenna that suppressed harmonics but with a larger size was reported in reference 11. Okay, now we move to the antenna design. Okay, figure 1 shows the geometry of developed antenna. Okay, this antenna incorporates dipole arms, 2 parasitic elements, and open circuit stub, and a compact tapered balloon as labeled in figure number 1. This antenna structure is a dual-sided type integrated with a stub and balloon that suppress any undesired frequency. The antenna design begins with the development of a basic dipole antenna operating at 916 MHz as shown in figure 2. Figure 2 shows the image of the basic design of the antenna, while figure number 2 is the corresponding S11 versus frequency. Okay, figure number 3 shows the purpose of the antenna design. Okay, the top is the front view, while the bottom figure is a back view of the antenna. And then the corresponding dimension is tabulated in table number 2, table number 1. Okay, I will explain the antenna design. Okay, the parasitic elements are used to shift the second band operating frequency to 1.57 gigahertz by using parametric study. The antenna's various dimensions have been optimized to support operation across two frequency bands as specified for LoRa and GPS network application. The antenna was modeled using CST software and constructed with the wet etching method for publication. And then substrate FR4 substrate with a relative permittivity of 4.6 and thickness of 1.6 millimeter is used for fabricating the antenna. Okay, now we move to results and discussion session. Okay, two parametric elements are used to tune the antenna to a frequency of 1.57 gigahertz. Okay, it is done by varying the length of PM, PA, and PL as labeled in this figure. The effect of PM length change on antenna frequency as shown in the figure below. So this is how we changing or tuning the second frequency by using parametric study. Okay, we change the dimension of PM, PA, and PL. So in this slide, when we change the length of PM, we got this is the corresponding return loss. Okay, now this slide gives the effect of PL length change on the antenna frequency shown in the figure below. Okay, so this is the PL, and then this is corresponding when corresponding of S11 when variation of PL has been done. Okay, and then this slide is the result effect of a PA length change on the antenna frequency as given in this figure. Okay, and now this is the measured results for return loss and VSWR as shown in figure 4 and figure 5 respectively. Okay, figure 4 shows that the measure results where the antenna working at 61916 megahertz and 1.57 gigahertz as shown in this figure, while figure 5 give the measure of voltage standing wave ratio VSWR at a frequency of 916 megahertz and 1.57 gigahertz. Okay, and then the key benefit of this antenna include its small dual band functionality, efficient suppression of undesirable frequency. Okay, and then the bandwidth for the LoRa system is 7.8 megahertz, while the bandwidth for the GPS system is 24 megahertz. So this is the compact antenna that we have obtained. And then this is the features. It's compact, multiple band or dual band, and it has this ability to suppress the unwanted frequency. And then this graph shows the bandwidth of each band. For LoRa, the bandwidth is 78 megahertz, and for GPS, the bandwidth is 24 megahertz. And then this slide gives the table number 2, the comparison between simulation and measurement results for return loss and VSWR for both bands. So it is clearly shows that both simulation and measurement is a good in a good agreement in the results. Okay, and then this is the result for the radiation pattern. This antenna exhibit an omnidirectional radiation pattern as shown in the figure number 6, with radiation pattern displayed in the Y-X and Y-Z planes. So this figure number 6, shows the radiation pattern at frequency 916 megahertz, and where the E-plane E plane on the left side, while the H plane on the right side. And then for the second band, okay, this antenna exhibit an omnidirectional radiation pattern as shown in figure 7. Radiation pattern, figure 7 shows the radiation pattern at 1.57 gigahertz, showing the E plane on the left side and H plane on the right side. So now we move to the conclusion and future works. A dual frequency dipole antenna utilizing additional component, an open circuit stub and a compact tapered balloon has been presented in this work. The parasitic elements are used to precisely control the second frequency band set at 1.57 gigahertz. The antenna is also effective in suppressing undesired harmonics through the implementation of stub. By integrating the compact tapered balloon, the antenna's physical dimension can be minimized without compromising its performance. Okay, for future works, currently the simulation and the measurement results demonstrate that the antenna performs reliably across two primary frequency bands at 916 MHz and 1.57 GHz. To achieve better performance, this antenna will be developed using a low-loss substrate, such as a Roger RT Duroid 5880. By using this low-loss material, this step paves the way on the improvement of the antenna performance in real-world application. So that's all from me. Thank you very much.
Thank you, Mr. Anwar, for your presentation. There is any question from the attendee? You have? Okay. Mr. Anwar, I have a couple of questions to you. First, how do you know harmonics is among the signal or among the noise?
Basically, we can identify, we can say the frequency is harmonic or unused frequency if this is unused in our system developed. Okay, and then sometimes there are the harmonic or the unused frequency which will overlap with the system used at the similar time. So maybe when overlap happen, it will influence or degrade the performance of the system.
Okay.
How about
Also, excuse me?
Second question, what?
My question is how to suppress signal and receive signal. This is my question. How to know that this is a signal and this is the harmonics?
Okay, for me, in our study, okay, we focus on the dual operating frequency at LoRa in Malaysia around 916 megahertz, and for GPS is 1.57 gigahertz. So we simulate from and measured in the range frequency of 0 to 3 gigahertz. So any resonance will occur within the frequency. We assume as a harmonic for other frequency than these two frequency. So we can use stub to suppress that frequency. We want to remove from this range of frequency.
Okay. Another question. What is the bandwidth of GPS?
We obtain around 24 megahertz. I forget the exact value, but this is enough for to meet the requirement for the GPS bandwidth.
This is the center, but the bandwidth itself, how much mega or whatever? The band, it's I know it's 0.9 and 1.7 gigahertz, but the bandwidth How much the bandwidth?
I forget the actual value of the GPS bandwidth, but for our design, we got 24 megahertz. And then this value is meet the specification of GPS bandwidth.
Yeah. Thank you very much, Mr. Amar.
Welcome.
Thank you. Now we will go to the last paper in this session entitled Semiconductor Manufacturing Industry Assessment, Challenges, and Future Trend. Go ahead, the author.
Thank you so much.
Yeah, I know, Mr.
Let me just share my presentation. Thank you.
Okay, I see your picture.
Thank you.
Dr. Khaled Tantawi. Yeah?
Yes, thank you.
Okay. Yeah, Sabir now.
Okay. Yeah, do you see my presentation? Okay, let me just move this away from here so I can see. Thank you so much again. My name is Khaled Tantawi, and I am an associate professor of mechatronics in the University of Tennessee at Chattanooga in the state of Tennessee in the US. The title of my presentation is Semiconductor Manufacturing Industry Assessment, Challenges, and Future Trends.
Could you, Dr. Khaled, could you enlarge the presentation?
Yeah. Let me just give me here.
Maximize, yeah.
Do you see it now full screen or not?
Very good. Go ahead.
Is it good now?
Good.
Okay.
It's good.
Yeah, so this basically this paper was prepared by the student working with me, and basically we were funded by the National Science Foundation to develop electric vehicle engineering technology program in Eastern and Middle Tennessee regions. So if we look at the semiconductor manufacturing industry, so there was a chip shortage in the years 2020 and 2021. The chip shortage of 2020 has put under the spotlight the semiconductor manufacturing industry again, which by that time has mostly relocated outside the United States. The United States accounted for 37% of the world production of semiconductors in the early 1990s. And ever since that time, it has steadily decreased, and it was only 12% by the year 2022. So it has migrated outside the US. The migration of the semiconductor manufacturing industry was so aggressive that the last time a major semiconductor fabrication plant opened in the US before the chip shortage was over 20 years before that. So we're talking about in the early 2000s. By the mid-2010s, the industry was well overshadowed in the United States. So this is the state of the industry prior to the chip shortage. Now, let's talk about the industry just to introduce it. So basically, there are three major steps in semiconductor manufacturing. There's the design stage, there's the manufacturing stage, and then there's the ATP, the assembly, testing, and packaging stage. The first two stages, they constitute the front end of the semiconductor manufacturing industry. They include photolithography and other processes that require high tech and processing. Basically, the ATP stage constitutes the back end of the manufacturing industry. So it's basically the back end processes in which the electrical chips are cut, wired, and tested. So of these three stages, the design and manufacturing stages require the most advanced technologies, like I stated, while the ATP stage requires a high level of manual labor. So it needs the man force. The complexity of the supply chain of the semiconductor industry is very sophisticated, that to produce a computer chip, more than 1,000 steps are needed, during which international boundaries are crossed over 70 times. So it's very, very well globalized. It's this industry. Imagine that you have to cross international boundaries 70 times. For example, like silicon may be produced, raw silicon may be produced in the US, then shipped to China for processing, then shipped to Japan, then to Korea, then to Malaysia, then Taiwan, and over 70 times to manufacture to get a computer chip. Now, here. So in the pre-chip shortage of 2021, let's look at the state of the industry in the United States compared to other industries. So this table that you see here shows the US share of the world's value-added manufacturing in different strategic industries. This is from 2019. For example, the aerospace industry, the US dominates 49% of the world's share in aerospace manufacturing. Medical equipment, 25%. Pharmaceuticals, 23%. Petrochemicals, 19%. Semiconductors, 12%. So it has declined, like I said, from 37% in the 1990s to 12% by 2020. Now comes the chip shortage of 2021. So after, as you know, after COVID-19, and there was a severe supply chain disruption, and now exposed the shortage of chips at that time. So while the semiconductor industry grew exponentially over the last 3 decades worldwide, in the United States it declined, like I said, from 37% to 12%, which was actually a lot sharper a decline compared to other value-added manufacturing. So value-added manufacturing in the United States dropped. It's also dropped, but it dropped from 30% to 17%. But the semiconductor manufacturing industry dropped from 37% to 12%. So it was a lot steeper in decline. As a result, the US was the hardest hit by the chip shortage in 2021. If you look at this table here, it shows the percentage of world production and demand by country in 2021. The United States here produces 14% of the chip production, but it demands 34%. So as you see, the shortage is extreme. It's extremely high, it's negative 20%. For instance, if you look at China, for instance, it's at 21% and 29%. So it's almost, they produce as much as they demand. Europe, 12%. Europe, Middle East, and Africa, 12% and 16%. Korea, 7%, 10%. Japan, 16, 8%. So so they had no shortage, basically, Japan and Taiwan. So this shows the state of the industry during the chip shortage of 2021. Now, let's look at the challenges that face the industry in the United States. So, number one, the main challenge is the underdeveloped ATP infrastructure. So, this is the back end of the industry, assembly, testing, and packaging. And this is the stage that requires the man force. So, this is very severely underdeveloped in the United States, with the US only accounts for, actually both Americas, both North and South Americas account for only 13% of the ATP facilities in the world. About 90%, the remaining 87 or 90% of the world ATP industry is located in 4 countries, basically China, Taiwan, Japan, and Korea. Without a proper local ATP industry that includes both a trained workforce and proper infrastructure, any efforts to revitalize the semiconductor manufacturing industry will be short-lived, because eventually companies, they will want to ship their products overseas, to be assembled and packaged and processed. So they want to be near these facilities, obviously. Number two, the next challenge is, of course, the shortage of the skilled workforce. So in order to have a successful industry, you need to have the properly skilled workforce. Now let's look at trends in the industry. So the first trend that we found was, of course, globalization. It's one of the most globalized industries of all manufacturing industries. Like I said, to manufacture a chip, it's on average it's going to cross boundaries, international boundaries, at least 70 times. So ever since the 1980s, semiconductor manufacturing has increasingly become one of the most globalized industries. Of course, due to the complexity of the manufacturing processes that involve highly specialized companies in each stage of the process. However, after the chip shortage of 2021, governments around the world they increased regulations that actually hinder globalization. But still, the globalization is the main trend for this industry. The top 10 semiconductor companies by market capitalization are basically NVIDIA, which is based in the US. And then, so if you look at these companies here, basically a lot of them, actually most of them are based in the United States and in East Asia. So this basically says where the industry is dominated. The second trend is robotization. So basically the incorporation of industrial robots in the industry. Now, industrial robots, the main market for industrial robots historically was the automotive industry. About 70% at one point, about 70% of industrial robots were located at automotive manufacturing plants. However, in 2020, for the first time in history, the electronics industry actually was the largest market for industrial robots. So this is evidence in the annual reports of the International Federation of Robotics, which show a breakthrough taking place in 2020 in the history of industrial robotics, with the electronics industry for the first time becoming the biggest market of industrial robots, a position that has always been firmly held by the automotive industry. So these are the two trends that I want to discuss. There's also other trends, but basically these are the main ones. In conclusion, in this work, we analyzed the state of the semiconductor industry in the United States. The industry witnessed a sharp decline that continued for 2 decades prior to the COVID-19 pandemic. The chip shortage of 2021 uncovered a steep shortage in the United States. The main challenges that face the industry in the US include number one, the assembly, testing and packaging ATP infrastructure is severely underdeveloped in the United States. Number two, there's a need for skilled workforce for the industry, this industry. The trends in the semiconductor manufacturing industry include globalization and robotization. Thanks. This is the end of my presentation.
Thank you, Doctor. Is there any question? You are reporting on the status of semiconductor industry, Dr. Khalid. That's true.
Yeah.
What's the problem? Is there a problem with the silicon now? We have to find a new material, or what is the problem? What is the challenge which we are facing in the semiconductor industries now?
Yeah, so this is actually another trend, which is basically the materials. Yeah, I mean, silicon is still the dominant material. They have been, of course, if you look at the research and in literature, they have basically developed many materials that potentially can be alternatives for silicon. But still, there are a lot of challenges for them. Basically, the main ones being cost and underdeveloped infrastructure for those materials. So silicon still is going to continue to be the dominant material for at least probably 1 or 2 decades at least. But some scientists report that it has reached the end of its spectrum. So basically, there's no more. So right now we have the most sophisticated technologies that can incorporate transistors in a single, in a confined space, in a small space, and it's basically there's no more. They cannot basically put more transistors in a single space as much as they can. More than they can do now. So this is the main challenge, and it's basically it's due to the material itself, the shortage in the material itself. So it's basically right now you have reached really the end of the spectrum of the silicon as a material. But if you wanna look at other materials, they're still severely, let's say, I don't want to say, but significantly less comparable to silicon. So it will continue to be the dominant material for at least the next 10 or 20 years at least.
Okay, thank you, Dr. Khalid, for your nice presentation. Thank you very much.
Thank you so much. Thanks.
We reached to the end of this session. Inshallah, we will start the next session after 10 minutes from now.